To start a series of videos relating to all the lessons. Starting one is going to be units and dimensions. So the first part is going to be theory of units. No video will be longer than 25 minutes. The first video is going to be somewhere around 20 minutes. There will be some other videos like 10 to 15 minutes series of videos. The first one is going to be units, theory of units. After that, there are some calculations of prefixes. That there will be a series of videos. This is the first one. By the way, another thing, before moving to that, I have to tell you one thing. Just watch the video. You can't learn anything. So you have to watch it with writing the notes. If something there are some theories, and I use certain interactive board rather than of this conventional board, because in that one I can show some theory and show some animations and many other things. So I'm going to use that. Stop the video and pause it and write something and try the calculations. That is the best way of learning. Let's move to that board.
Hi there. Now just today let's learn units and dimensions. So just before learning what is units and dimensions, so we have to learn something like learning objectives of units. But the first part is going to be all about the theories of units. This entire video is going to be focusing on theory of units. If you have some kind of misunderstanding about the basic theories of unit, this is the video that you might be looking for. Actually, you are looking for. So firstly, to standardize, let's see what is that standardized thingy. So have a good look at here. Here you may see now different things. So like this, informal units of measurements. What are the informal units of measurement? Technically, hand span. When you span your hands, expand your end of your thumb to your small finger is going to be the hand span. So normally it's a rough measurement. So for a small child to very big hand person, so they have different size of hand span. And the cubit, it's also the same type of stupid unit. Why do I call it stupid? Because person to person it's going to be changed. Imagine you take some 10 cubit unit when you are at the age of 10 years old, and you are now going to take the same unit when you are 16 years old, 17 years old, and now it's going to be somewhere like 7 cubits. Why? Because now your hand has a big your forearm has a grown into longer. Now arm span is going to be the same, and the pace as well as the foot span all going to be really stupid considering the modern day technology. But for the past few years, like of some hundreds of 2,000 hundreds of thousands of years ago, they hadn't had specific units and people didn't know about those, and they had certain rough idea. So it was a really good deed. It was not stupid, come to think of their age, but it's not standardized. So the people may use different words for this one. So they had a very big mess with understanding it. So now have a very good look at here. Measurement units, like of imperial units. This is standard because the yard may never change its distance from one place to another, because a yard is a yard. Whenever you measure it in England or Sri Lanka, India, Australia, America, wherever, it's a yard means a yard. In a cricket pitch, you know that there's a distance between two wickets is 22 yards. And inches, we measure our height using inches, like so we say 6 foot 2 inches, like that. And the tablespoon, cup, and cup we use mostly in cooking stuff. Add 1 cup of milk, 1.5 cup of butter, like that. So pint and a very small thingy we measure, like so what ounce, especially in measuring herbals, and ounce and pounds and quart and gallon. These are the types of units, but still not standardized in terms of modern physics, modern day, even in the classical physics in the past few eras. So we have to use something really specific and worldwide recognized. Imagine if you take a length of 1 meter, if you measure 1 meter from A to B, so a Japanese scientist may take the same distance according to your instructions, and you can order something from China right nowadays. So they manufacture it for you and send it. If you measure certain box, right, if you design a certain box to choose your DIY project like circuit or something. So you send them your dimensions. How you send it, like 6 centimeter and 10 centimeter and 2 centimeter. So the Chinese person get the detail from your internet and from your quotation, and he take it and he standardize it and make a mold and produce it and ship to you. You will receive the same thing like what you made as your model. Can you understand? That is the importance of the standardization. So no different words, meter, centimeter, millimeter, all are standardized, but not the SI units. There's this thing called SI units. Let's go back to the previous page again. In that one, to convert from one unit to another. So you have seen this thing in cricket matches. They just mark the speed likes of 150 kilometers per hour. So the stuff may be written in miles per hour in some 90s, 90 miles per hour. So why is that? Because it's a conversion. You have to convert from one unit to another. 50 centimeters. You to convert it to man unit. What is the man unit? Meters, it's like a 0.5 meter. These are the competence levels you have to learn. Next up is like dimensions. Right? So get some clear idea. What is it? Whether it is a length, whether it is a mass, whether it is a time. So these things, and this is going to be with the third video stuff, not in this one, so don't worry. And derive an equation to differentiate among them. So these three things are going to be discussed in the very next third video. So now let's go for units and understanding what are the basic units. So physical quantity. What is a physical quantity? All quantities in terms of laws of physics can be expressed, which can be measured, is called the physical quantity. So you may write this definition. And for example, distance, speed, mass, and force. What are the laws of physics? You will learn in many laws of physics. Like best thing you have already come across is like of what? Newton's law of motion. There are many other laws. So units and derived units. Measurement. What is a measurement? In our day-to-day life, we need to compare the magnitude of different quantities can be done only by measuring them. Even if you are a good cook, you may have just try to make a cake. So the cooking guy likes of certain YouTube channel, they may instruct you to do 200 grams of butter, 150 grams of flour, and add 2 tablespoons, spoons of vanilla or something. These are really I don't know the exact thing, I'm just randomly saying these things, so you may have done it. Or measuring anything according to certain instructions. So measurements can be just comparison of unknown physical quantity with the non-physical quantity. What is the non-physical quantity? Imagine a meter ruler. According to centimeters, meters, these are the non-fixed quantity. You compare how many quantities are there relative to your standardized method. Unit, a fixed physical quantity, but the real definition is what? The quantity used as a standard for measurement is called a unit. For an example, we say that the length of a classroom is 8 meters. We compare the length of classroom with the standard unit, even your height. So according to my height, it's like a 72 inches. In terms of centimeters, it's like a 183 centimeters. So you guys may compare your height, your weight, your anything. In compare of my weight is like a 70 kilogram. So you may get your own. So these are the measurements you may use. And 1 liter. So you according to biology, I remember, I don't know exactly the value. It's like a 5 liter in a grown man's body. It's like 5 milliliters in average of blood. So there are many measurements we can make using the fundamental and derived measurements. So this is really easy thing you already know. And the very next part, the characteristics of standardized units. A unit selected for measuring a physical quantity should have following properties. It should be a well-defined, and the concept should be clear. Okay, well-defined. Oh my god, what is known as well-defined? Let me show you. Here, 1 meter. You have to define the 1 meter. So it is like a 1 meter is the length of path of travel by light in vacuum during a time interval of this much. Actually, you don't want to remember that, but there is a certain physical exact definition in physics books, so but you don't want to remember, right? Most of the students just asking me, sir, I can't remember this thing. I just ask them, why the heck you need to remember them? I told you to don't look at that even. So actually there is a certain specific definition, specific measurement they have taken to define that. So kilogram of mass is platinum iridium prototype, which was approved by Carbon, even I can't pronounce the name because it's a French name, museum held in France, in Paris. It is like 1889. It's kept by the Bureau International Depots of Messeries, something like that. So it's a different simple thing you don't want to worry about. And second, and those never, but this part, this is something you will have. So for the very next part, have a good look at. It's like a ampere. So according to the ampere thing, you don't really want to worry about because it's a really simple thing. And ampere you have to. So other things like Kelvin you have to, but candela and mole you have to. These are the only thing you have to know. Otherwise, any of those you don't want to worry about. Even these things, if you are a chemistry student, you need to know about mole. So Kelvin is going to be learned in physics, in thermal physics, heat lesson. So not now. And the ampere in current and current electricity and the magnetism, not now. So don't worry. Still, you don't really want to know about any of these, but you have to know one thing, that there is a well-defined standard definition for them. That's the only thing you want to know, nothing else. Okay, come back to here. It should not change with change in physical conditions like temperature and stress, whatever. Imagine if the distance of the standard unit of meter change with the temperature. Normally you know that with the temperatures expands and shrink. It doesn't matter as long as the standardized unit is defined for some specific length. So the standard unit is not going to change with any other conditions. It's universal. It should be suitable for size, neither too large or too small. Okay, because you will learn this thing very soon, but I will keep it for future usage in this video, specific video. It should not be changed with place or time. If you measure 1 meter in England, the same meter should be measured in Sri Lanka, Africa, Antarctica, in this space, wherever. It doesn't matter. So and it should be reproducible. That means it is not the only unit. You can have billions of trillions of millions of quadrillions of the same unit, likes of measuring length from sun to earth, something like that. So you can reproduce it and internationally accepted, because these are internationally accepted. That's what the standardized characteristics of the unit. In your term test, they may ask these properties. At least you should remember 3 of these. You don't want to remember all 6, because they may ask write 3 characteristics of standard unit. You at least remember 3 to 4 of these. It's better to remember all 5. These are something to you to remember. Okay. Now in the next one, fundamental. What is a fundamental physical quantity? The physical quantity which independence of other physical quantities. In mechanics, mass, length and time are called fundamental quantities, which units of these fundamental physical quantities are called fundamental units. Have a good look at mass, length and time. So we basically measure these things in regarding of what? Certain units like kilogram, gram and pound. These are standard, not international standard SI units, but still standard. Length, meters, centimeters, foot, because these are really well defined. And time, in all the sectors, it's measured in seconds. Now let's go for a derived one. How to derive? That means you express in terms of another. You know length, A to B, it is a basic unit, but area is not basic. It's a derived. Length into breadth is known as area. So you have to multiply length into breadth. Its length is a length, but breadth It is also over length, even a depth, height, whatever the name it is. If you measure using a meter rule or something of a certain length measuring stuff, it is a length by length. It is what? M to the power 2, standard units, M to the power 2. Or if you measure it in terms of centimeters, cm to the power 2, right? Likes of that. So the speed is equals to distance over time. Distance is measured standardly. Length, it is a time, so ms minus 1 or cm is minus 1, whatever it is, it can be, or kilometers per hours in terms of cricket ball thingy. Units for derived physical quantities are called derived units. These are not basic units, because basics are meters and seconds separately, but if you mix them in a certain equation, it is going to be a derived unit. Very simple. Now let's move for the other ones. So some systems of units. So really you have to be really wondering and to know all of these things together. First, measurements of physical quantities. Now following systems are commonly used. CGS. So it's really easy because centi, grams and seconds. That's why the name of CGS, centimeters, units mass, and mass is in grams, and the time is in seconds, CGS. FPS. For length measurements, it's like a foot. Mass measurements is a pound, and the time measurement is seconds, CGS, foot and pounds and seconds. It's really easy. And MKS system. What is MKS system? So what is it? In the unit is in meters, and this is in kilograms, and this is in seconds. And the SI, it's more like SI because all in standard units, but there are some other 7 units, so some other 4 units included. So SI units are a really good standard system. This is an improved extended version of MKS and called international unit. Internationally extended ones are being used here. So if you read these three by pausing the video, just pause the video and read this part. I'm not going to read it out for you because you can read it. So pause the video and watch. So next, go for the next up. What is next? So the basic 7 units. What are? Length, you measure that in terms of meters. Mass in terms of kilograms. Time in terms of seconds. Temperature, never in Celsius, in terms of Kelvin in physics applications like thermodynamics. And electric current, it is in ampere, and the luminous intensity is a candela. You don't want to worry about this one. It is just only a name. You should only remember the luminous intensity, that is candela itself. You don't want to apply this in anywhere in A-level physics, even in the university first 2 years, guaranteed. So the quantity of matter, it's a mole, right? Symbol is mole. You may have to, even you are not a chemistry student, but in physics you have to apply in somewhere, so get used to some small extent of mole calculations. So these are the basic 7 units. Apart from that, supplementary. What is a supplement? Now have a good look at, if you are a gym guy, when you enter into gym, you in the first place you are like a very rickety learning guy, oh very huge fat guy, but the muscle mass is very thin, but you want to be the guy likes of a certain American actor or an Indian actor or any of your country's actor, likes of having a very fit body with 6 packs and just arms and biceps and all the things. So you need to eat well than a normal person. So sometimes to build your muscle mass, I'm talking about the muscle mass, not about the fat mass. So to get extra amount of what something rather than of main meal. So these things we call a word called what? Supplement. We take supplements if you are a gym guy and reading for some meets and other things, competes in tournaments and meets. So you have to build your muscle using supplements. Normal people don't take. So for scientific calculations, for some cases, we used to learn plane angle. It's in radian. this is in A-level standard, but solid angle it's only a word, so we just need to remember it as a word. That's it. It's something like luminous intensity. It's just a name. So what are the advantages of SI system? It is coherent system. Units derived units of physical quantities are easily obtained by multiplication of division of fundamental units. So that means you can multiply them together. Good example is the previous one. ms minus 1 for the speed and ms minus 2 for the acceleration, and for the mass it's like a kilogram, so we can apply it the same way. kg ms minus 1 for the momentum, kg ms minus 2 for what? Force. I will teach you this part very soon. So these are the basic things you want to know. And its rational system of that 1 unit of physical quantity is joule, is unit for all the types of energy, whether it can be a heat energy, light energy, mechanical energy, or chemical energy. What type of energy it is, it doesn't matter. It's a rational system. We can measure the same energy use of what? Joule, because we know something called conversion of unit. So, and then the next part is the metric system of examples, like you can express it in powers of 10. 10 to the power 3, 10 to the power 8, 10 to the power 9, 10 to the power 23 for mole, 6 into 10 to the power 23, that's for mole. Any of these, or any negative exponent as well. 1.2 into 10 to the power minus 9 coulomb, you can write it like 1.2 nanocoulomb. You will learn very soon what this really is. Okay, you will learn really very soon what this really is. Okay, next up, so the supplementary angle is like a radian, so the radian thing. So these are really simple thingy you need to know. Okay, and there are some important units of length, so like so about 1 micron. So the micrometers, microns, so meters, and it's like in centimeters, like 10 to the power minus 3. And angstrom we mostly use in measuring atomic level radius, and Fermi. So this is something you will have to learn in university. Extreme cases, sure, I'm not going to take. And a light year, you have to. It's like a distance that light travels within 1 year. It's a very long distance. Imagine it takes only 8 minutes to reach light from sun to earth. Okay, only 8 minutes. So can you imagine the distance that may travel from one place to another from light in at empty space? It's going to be a very enormous value. Okay, so light years. And apart from that, so some other units like electron volt. What is an electron volt? It is a measuring units of energy, not voltage, not charge. It is actually measuring unit of an energy. Small level of energy exchanges take place in atomic level. You have to use the unit called electron volt. These are the basic theories of stuff. So the next thing is going to be something like what supplementary units. I'm not going to reach that part in this exact video because it's going to be really tedious if you learn the same thing. And just learn this thing and get ready and get all the doubts cleared, and I'll teach you the supplementary units, right? And the other things like what prefixes. It's really important. Prefixes are going to be really important. How to use this prefix, how to convert one form to another. Good example like nano to pico, like this. How to convert from one to another. There are certain specific methods to be applied. So stay tuned. And
thank you for watching the video. If you are impressed with the video, just click the subscribe button and like and add some comment. It's really going to be really valuable for me. And another thing, if you want to join for my class for permanently, just drop a message to this WhatsApp number. Thank you very much.